Hello folks, I'm just going to hit the record button. Give me 1 second, I'm just going to hit the record button. Hello, hi. Good evening to all of you. I hope you've all had a good time taking the test. It's excellent paper. Several very tough, beautiful questions. I think we're going to have fun discussing the questions. Good evening and namaste to all of you. And so, good to see you. Good to see you on a different platform. But I think all of you know how YouTube works. Practically no one here in our audience who does not get YouTube. And so, so first of all, let's get the technological part out of the way. Please type in comments saying, hey, whether that you can see me and hear me clearly. So just type in saying, hey, audio and video are working fine. I can see Anupama Jagdish saying test was fine, test was lovely. Even I loved the test. I quite enjoyed myself. It was tough. It was really tough, but it was fun. I like the ones that are fun and tough. Ashmita, namaste. Vishwa says hi guys. Ram Kumar Mani, Rishimant, all hi to all of you. Krishna Kumari, hi. Yep. Test was amazing. Preetika Tanglu, yes, definitely. It was amazing. Amazingly, tough, but really good. I just want to make sure that the audio and video are working. Thanks, Vishwa. Vishwa has to reaffirm that for me, saying audio and video are working fine. I'm definitely not going to discuss, I'm not going to take the time to discuss the results and marks and scores and all that. You will have access to that to know how much you have scored sooner or later. So check that out. I will tell you how you can access your score and all of that. But I'm more interested in discussing the paper itself, discussing how the questions could have been solved. Some of these are nice, tough, challenging questions. So the idea is to try these challenging questions, maybe not get them right, and then scramble back and learn how to solve them. The whole exercise is in a bit to learn, not bit to get marks and scores and all of that. Right? So I'm going to spend time solving each and every single one of these questions. Hopefully we'll have tons of fun doing that. Right? Lovely. I hope you've all got the tech. I hope you've all signed into Google Classroom. I hope you all know what questions we're going to discuss now. So here we go. I'm just having one look at the chat. So the test was very tough. We've joined the classroom. That's good. Test was fun but challenging. Definitely yes. Mother also said it looking at college level. Definitely not college level. The syllabus and portions are pretty much exactly your level, but challenging. Nevertheless challenging. When we see the solutions, you'll realize that with whatever you have learned so far, we can attempt these questions. I don't want to get them right. I just want to be able to attempt them. You can try them and attempt, then you're going somewhere. That's all my objective is. You need to know how to have a good starting step. Throw something in, try this number, put just that, substitute this, substitute that, something like that. As long as you can substitute something and try, you're in a good place. Right? Lovely. Once again, namaste to all of you. And I'm going to jump into the questions part. LCM of A and 220 is 880, and LCM of B and 210 is 1050. If A and B, not and B, if A and B are perfect squares, find B minus A. Finding LCM, doing by the long division common method is one approach, but the approach that I really like is to prime factorize. So I'm going to take 220 and prime factorize it. This is 2 into 110, 2 into 2 into 55, 2 into 2 into 5 into 11. This is 2 square into 5 into 11. This is 220. And then we have A with us. And the LCM is 880. 880 is nothing but 220 into 4. That much I know. So it is 2 square into 5 into 11 into 4. Or this is going to be 2 power 4 into 5 into 11. Nice. Wonderful. Now if I take this LCM, this should be a multiple of this number and this number. Right? That is it should be a multiple of 220 and of A. It should be the smallest possible number that's a multiple of both. First of all, this has 2 power 4. 220 has only 2 square. If A also had only 2 square, then LCM will also have only 2 square. If A also had only 2, if A had only 2 power 1, LCM can have only 2 square. If A had 2 cube, LCM will only be 2 cube. This is 2 power 4, or A definitely has 2 power 4. Let's come to 5 and 11. A could have a 5 power 1, A cannot have 5 square. Then a multiple of A has to have at least 5 square here. A cannot be 5 square. Again, A cannot be 11 square. A can be 5, A can have a 5, A can have 11. And 2 power 4 it definitely has. It could have a 5, it need not have a 5. Even then it will work. It could have 11, it need not have 11. It cannot have any other prime. A cannot be 2 power 4 into 7. Otherwise, the LCM will also have a 7. The LCM has only 2 power 4, 5 and 11. It has to have 4 fours, 4 twos. This number has only 2 twos. So, A has to have 4 twos for sure. 5 and 11, it may have a 5, may not have a 5. It could be into 5, it could be into 11, it could be into 5, into 11. Any of those will work. This will still hold good. Now, what are the other bazooka we have? We know that A and B are perfect squares. And so, that means this number has to be a perfect square. 2 power 4 is 16. 16 is 4 square. That works. If it had a 5 or 11, 16 into 5, 16 into 11, 16 into 5 into 11, they are all not perfect squares. Or A cannot have 5 or 11. A has to have only 2 power 4 or A is 16. Done. Prime factorize this, prime factorize this. Then we want A to have the prime factors that will combine to give this. If A did not have a 2 power 4, the LCM cannot have 2 power 4. So, A has to have 2 power 4. 2 power 4 is in A for sure. 5 and 11 may or may not contain. This 5 can come from here, 11 can come from here. So, A has to be 16 because it's a perfect square. Same approach for B. I'm going to take 210 and prime factorize it. 210 is 2 into 105, 2 into 3 into 35, 2 into 3 into 5 into 7. So, 210 is 2 into 3 into 5 into 7, and B, the LCM equals 1050. 1050 is 210 into 5, or the prime factorization here would be 2 into 3 into 5 square into 7. Now, the LCM has 5 square in it. LCM is a multiple of 25. So, this number is only a multiple of 5. So, the second 5, B has to be a multiple of 25. If B had only one 5, LCM would also be have only one 5. If B has no 5, LCM can have only one 5. Or B definitely has to have 5 square sitting here. It cannot be 5 cube because then this will become 5 cube. It cannot be only 5, then this will be only 5. B has to have 5 square in it. Apart from that, it may or may not have a 7, may or may not have a 3, may or may not have a 2. That doesn't matter. It definitely has 5 square in it. Now, we know B is also a perfect square. 5 square is 25. 25 is a perfect square. But 25 into 7, 25 into 3, 25 into 2, 25 into 3 into 7, none of those can be perfect square. Or B is just 25, not anything more than 25. B is 25, A is 16, B minus A is 25 minus 16 equal to 9. This part is called prime factorization. Should have the ability to look at each number in terms of combinations of primes. 210 has to be 2 into 3 into 5 into 7. 1050 has to be seen as 2 into 3 into 5 square into 7. You have to see each number as a combination of primes. Then all these inferences become far simpler. I'm going to have one look at the chat window. B is 25, that is 5 square. A is 16, that is 4 square. 25 minus 16 is 9. Lovely. There's not too many doubts on this. So I'm going to go to the next question. It's been a very tough question. You can see that only 16% of students have got it right. That's very tough, right? 100 people take this question, only 16 get it right. That means the question is tough. It's flummoxed people. It's been not that easy, which is important. I don't want you guys to be conditioned in a world where you just do nice, easy questions. I don't want you to be happy only if you get 90 out of 100. The best learning experiences happen when you take 20 questions in an exam and you're able to attempt only 4 or 5. That's when you hang in there and say, look, I know only 4 or 5, I will get it right. I would somehow try this and try that. I do trial and error and then shift to this method. That's when new ideas open up. Your grit increases. Super important. So don't worry about the scores, marks, how many you get right, how many you get wrong, how difficult it is, none of that. You have to say, okay, interesting question, I'm going to try it. I'm going to do different trial and error combinations for it. I'm going to poke around with some numbers, learn some new ideas, try in different methods. That's important. Right? Lovely. Let's go to the next one. What is the smallest natural number that has all the digits appearing at least once and is a multiple of 45? Smallest natural number that has all natural numbers, all the digits appearing at least once. Digits are 0 to 9. That's a multiple of 45. So first of all, I'm going to forget this 45. We'll come there. I want to think of the smallest natural number that has all the digits. Digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to find a number that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0 also, but as small as possible. My small digit should come to the left, my large digit should come to the right. I'm looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. I've forgotten 0. Put 0 here. Does just work? It doesn't work, right? 0 is a very small digit. I shouldn't be putting it in the units place. I should be putting it right to the left, to the extreme left. It cannot be the starting digit because then it will become a 9-digit number. You cannot start a number with 0. Or the smallest natural number that has all the digits 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. Nice, brilliant. Now we want the smallest natural number that has all the digits in it that also happens to be a multiple of 45. Our number is not a multiple of 45. That I know. How do we know that? Because it ends with 9. A number ending in 9 cannot be a multiple of 45. Why not? Because 45 is a multiple of 5. So any multiple of 45 should be a multiple of 5. Or it cannot end in 9. It has to end in 0 or 5. Brilliant. So this number has to end in 0 or 5. So 1, 0, 2, 3, 4, 5, 6, 7, 8, 9 is a good interesting number, but it's not a multiple of 45. But it has given me a clue. The number I am looking for should have the last digit as 0 or the last digit as 5. That much I know. One inference I've made. Because 45 is a multiple of 5. Any multiple of 45 will also be a multiple of 5. I know that a multiple of 5 ends in 0 or 5. So this has to be 0 or this has to be 5. But every number ending in 0 or 5 is only a multiple of 5. I want our number to be a multiple of 45. 45, I know I found a multiple of 5. What else is sitting inside 45? 45, quite beautifully, is 5 into 9. If I have a number that's a multiple of 5 and of 9, it will be a multiple of 45. For it to be a multiple of 5, the condition is very simple. My last digit should be 0 or 5. Nice, easy, wonderful. For it to be a multiple of 9, I have a beautiful condition that the sum of the digits should be a multiple of 9. If you add all the digits, the sum of all digits should be a multiple of 9. That I know, the test of divisibility by 9. First of all, I have known that this has to be 0 or 5. I know that these digits should all come. I'm going to check whether if I add all the digits, is that turning out to be a multiple of 9. Let me check that. Suppose I add all the digits of this number. 1 plus 2 is 3, plus 3 6, plus 4 10. Till here we have come to 10. 10 plus 5 15, 15 plus 6 21. Till here we have come to 21. 28, 36. Till here we have come to 36. 36 plus 9 is 45. So this number is a multiple of 9. Beautiful. If I have all digits 1, 0, 2, 3, 4, 5, 6, 7, 8, 9, then I have a multiple of 45. Not just this, I have a multiple of 9, sorry. Not just this, now I know the test of divisibility is just sum of the digits. I can mangle this and put it in any order. So instead of saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, I can say 1, 2, 3, 5, 6, 7, 4, 8, 9, 0. 5, 6, 4, 3, 2, 1, 8, 9, 4, 0. Any order. I can, if I have these digits, any order I put them in, I'll get a multiple of 9 because sum of the digits is a multiple of 9. Now, I know that these digits work to give me a multiple of 9. I know my unit digit has to be 0 or 5. Unit digit were 0. The smallest number possible will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. number itself. Beautiful number. It has all the digits. It's a multiple of 9. It's a multiple of 5. It's a multiple of 45. Small digits come to the left. Higher digits come to the right. Looking all good except the 0 is sitting here. Our number has to end in 0 or 5. We put it as 0. This is the best case scenario. But maybe we can do better than this if we choose the last digit as 5. Why? Because if I put the last digit as 5, my second digit can be 0. That will obviously be better. What do? 1, 0, 2, 3, 4. This cannot be 5. That's sitting there. 6, 7, 8, 9. This is the best case scenario. All digits appear, condition satisfied. Sum of all digits is 45. Numbers are multiple of 9, condition satisfied. The last digit is 5, condition satisfied. I put all small digits to the left, larger digits to the right, except 5, because that should be 5. I cannot start with 0, so I put 0 right next to the 1. This number works. 1, 0, 2, 3, 4, 6, 7, 8, 9, 5. The last digit has to be 0 or 5. Sum of the digits has to be a multiple of 9. Sum of the digits is a multiple of 9 anyway. So the sequence of digits does not matter at all as far as divisibility by 9 is concerned. Plonk in a 5, write these in ascending order as much as possible. Why do I say as much as possible? It is not 0, 1, 2, 3, 4, 5. It is 1, 0, 2, 3, 4, 5 because we cannot start with 0. That's it. We are done. This number, 10-digit number with all digits, starting with 1, then going to 0, 2, 3, 4, ending in 5, is the smallest natural number. That's a multiple of 45. Saying my voice is very low. This is coming from Disha. I will amp it up, Disha. I will speak louder and clearer. Hopefully, just moving the mic closer should help. The natural number can have a 0 before a number. No, it can, but then if you put the 0 here, it will be just 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not a number that has all the digits. 0, 1, 2, 3 is not a number. It's only 1, 2, 3. You can put a 0 before, but it will be called only 123. If I put 0 right at the first digit, then that has to be ignored. Then the number is the number without the digit. Then there will be no 0 in our number. We cannot start a 10-digit number with 0. If we do that, then we are effectively talking only about a 9-digit number. Lovely, lovely. Saying volume is now clear. Thanks, Disha. I will speak louder as well. Lovely. Let's go to the next question. Doing well. Nice questions. This again has been a very tough question. Not too many have gotten it right. That's all right. That's all right. As I keep saying over and over again, getting questions wrong, not being able to solve them is a blessing. You rarely ever learn something with easy questions. Consider 5 integers A, B, C, D, and E. When added pairwise, they yield sums -1, 3, 5, 6, 6, 8, 9, 12, 13, 15. It took me a long time to just understand this question. Find the largest of the 5 integers. And so they're all A, B, C, D, and E. Maybe some of these digits are equal, maybe they are not. Let me see if they will be equal. If 2 digits are equal, then if A and B were equal, A plus C would be same as B plus C. A plus D will be same as B plus D. A plus E would be same as B plus E. The sums would repeat. What this question is saying, when added pairwise, if I add A and B, I get one sum. B and C, I get one sum. D and D, I get one sum. A and D, I get one sum. C and E, I get one sum. B and E, I get one sum. Somewhere in some order, all those possible sums are these. I don't even know how many sums can be created. But in some sequence, they are like that. We want to find the largest of the 5 integers. First thing to infer, yes, a bunch of these numbers are not equal. Only 2 numbers are equal. Right? Because a bunch of these are not equal, I can straight away say that no 2 numbers are equal. Right? So A, B, C, D, E. I want to say, assume the numbers are A less than B, less than C, less than D, less than E. I'm assuming them in some order, descending order or ascending order. A less than B, less than C, less than D. And now, what will be the smallest possible sum that will be adding these two? So if I add the smallest number and the second smallest number, I should get -1. Or A plus B is -1. Smallest possible sum is A plus B. Nice. Largest possible sum is D plus E. If I add these two, I get 15. If I add these two, I get minus 1. Sorry, minus 1. Nice. So far, so good. Now, let's go to the next sum. What will be the next sum? The smallest one is A plus B. The next possible sum could be A plus C, B plus C, A plus D. Think about everything else possible. A plus B. Instead of B, we could put C. We can have A plus C. A plus D, A plus C will be more than this. B plus C will be greater than A plus C. To A, I am adding C. If I add B and C, that will be higher. So my smallest sum is minus 1. The next sum, next smallest, A plus C should be 3. One step higher. Instead of B, I have to put C. That's when I'll get my next sum. Exact reasoning this way around. D plus E is 15. The next total is 13. E plus C should be 13. Largest and second largest is 15. Largest and middle number should be 13. Nice, brilliant. So these are the equations I'm going to work with. Now what am I going to do? I'm going to anchor this around some variables, make some inferences. And so smallest and second smallest is minus 1. Smallest and middle number is 3. So think about this. I have two numbers, they add up to minus 1. I take away one and replace it with another. My total increases by 4. My total goes up by 4. What does that mean? Instead of B, I put C. My total goes up by 4. What does that mean? This number C is 4 more than B. Brilliant. Now I'm going to imagine these numbers on a number line. A sits somewhere here, B is next, and then 1, 2, 3, 4, B plus 4 is C. Nice. So position this like that. Same idea, E plus D is 15, E plus C is 13. E plus D is 15, E plus C is 13. Nice. Instead of D, we put C, and the total falls by 2. Or C is 2 less than D. From D, I subtract 2, I'll get C. Or from C, I add 2, I'll get D. Or another 2 more gives us D. C plus 2 is D, which is nothing but B plus 6. Nice. And so, instead of having A, B, C, D, E, we've got A, B, B plus 4, B plus 6, and E somewhere here. We do not yet know anything about E. Right? So we'll come there. A plus B plus 4, A plus B plus 6, A plus E. These are all different combinations. E plus B plus 6, E plus B plus 4, E plus B, E plus A. These are different combinations. Right? Now I'm going to look at the totals. A plus B is equal to minus 1. E plus B plus 6, E plus B plus 6 equals 15. To E, if I add B plus 6, it gives me 15. Lovely. So A plus B is minus 1. E plus B is 15 minus 6, which is 9. So I'm going to write this down. A plus B is minus 1. E plus B is 9. Nice. Think about it. Instead of A, I put E, my total goes up by 10. Or E is effectively A plus 10. Another beautiful inference. So I'll not write E as E, I'll write E as A plus 10. Now I've got A, B, C, D, E in terms of A, B only. Now I can make a series of other inferences, see if I can make some conclusions. I'm going to re-evaluate it. A plus B is minus 1. A plus B is minus 1. A plus B plus 4 is 3. This is A plus C. The next total is 5. Be A plus B plus 6 is 5. So this is A plus B, A plus C, A plus D. Likewise, from this side, A plus 10 plus B plus 6. A plus 10 plus B plus 6 is 15. A plus 10 plus B plus 4 is 13. The next lower one is 12, which would be E plus B or D plus C. I can either take this and this, or I can take this plus this. That will be my next sum. If I add this plus this, A plus B plus 10, A plus B is minus 1, plus 10 would be 9, whereas this plus this should be, I have a total of 12. So I am not doing E plus B, I am doing D plus C to give this 12, the third number in the list. And so this plus this, the first two are E plus D, E plus C. After that, the third largest number could be E plus B or D plus C. E plus B, adding E and B gives us A plus B plus 10. A plus B is minus 1, this is 9. Third largest is not 9, it is 12. Or that means if I add these two, I get 12. So I know that B plus 4 plus B plus 6 is 12. 2B plus 10 is 12. Or 2B is 2, B is 1. I'm through. I get B as 1, put this as 1. A plus B is minus 1. So A should be minus 2. B plus 4 is 5. B plus 6 is 7. A plus 10, minus 2 plus 10 is 8. Totals, minus 2 plus 1 is minus 1. Minus 2 plus 5 is 3. Minus 2 plus 7 is 5. 1 plus 5 is 6. Minus 2 plus 8 is 6. 1 plus 7 is 8. 1 plus 8 is 9. 5 plus 7 is 12. 5 plus 8 is 13. 7 plus 8 is 15. All the totals match up. And so this is a beautiful way of solving this question. The smallest two add up to minus 1, largest two add up to 15, and then go step by step and keep on putting everything in as few variables as possible. You start with A, B, C, D, E. You make the inference that C is just 4 more than B. You make the inference that C is just 2 less than D. So B, C, D can be linked with only one variable. Good. Then link A and D. Go step by step and solve this. And there is a more algebraic method of doing this. This is also algebraic, but this is number line step by step. The more algebraic method of doing this, I'm going to outline that to you. When you get more comfortable with A and B, you have the totals A plus B, and then A plus C, A and D, A and E. Then you'll be adding B and C, B and D, B and E. Then we'll be adding C and D, C and E. To this we'll be adding D plus E. These are all the totals. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 totals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 totals. These all match up to each of these. Now if you add all of them, you'll have 1, 2, 3, 4, 4 A's, 1, 2, 3, 4, 4 B's, 1, 2, 3, 4, 4 C's, 1, 2, 3, 4, 4 E's, 4 D's and 4 E's. So 4A plus 4B plus 4C plus 4D plus 4E, all of them put together. All of these put together is 4 times A plus B plus C plus D plus C. With that, we can find A plus B plus C plus D plus C. Straight away. We know this is A plus B, we know this is D plus E. So we can find the middle number. All 5 put together we know. Smallest 2 we know, largest 2 we know. Middle number we can find. Once you find the middle number, everything else falls in place. That's the other approach, which is more algebraic. Not putting number line, making inferences, but writing A, B, C, D, E and then solving them. Right? Lovely. Nice and tough, challenging, beautiful, delightful question. So I'm going to load it up with adjectives, fine? But not easy. And I hope you're all trying. That's the most important thing. Lovely. I'm going to go to the next one. How many 6-digit numbers can be formed using the digits 1, 2, 3, 4, 5, 6, each exactly once, such that they are multiples of 11? All of these questions, I like starting with some number 1, 2, 3, 4, 5, 6. Nice and simple. Let's start with this. Now, I want this number to be a multiple of 11. If it turns out to be a multiple of 11, I already have one number. How do I test multiple of 11? You know the test of divisibility. Add these digits. Add these digits. 1 plus 3 is 4, 4 plus 5 is 9, 2 plus 4 is 6, 6 plus 6 is 12. Difference between this 12 minus 9 is 3. This number is not a multiple of 11. I know that if I add odd position digits and then even position digits, if I add this and then I find the difference is 0 or a multiple of 11, then I'm through. Now, obviously, the difference in this case is not working out, but I'm already on to a method. What is my method? I want the difference to be 0. So I'll balance this out. I put 3, 1, this plus 1 is this plus 1 is this plus 1 is this. Obviously, it won't work. So let me put it as 1, 2, 4, 3, 5, 6. 1 plus 4 plus 5, this is 10. 2 plus 3 plus 6, this is 11. Close. 11 minus 10 is 1, but I'm still not getting 0. Now I'm thinking, I shifted this around. Maybe there's a method to get here. What is that method? I want my digits to difference to be 0. Let me add all the digits. What is the sum of all digits? Sum of all this is 10, sum of all this is 11. Everything put together will be 21. I have to split 21 into 2 equal bundles. Only then I'll get my difference to be 0. That's not possible. If I put 21 into 2 equal bundles, I'll get 10.5, 10.5. That's not possible. Straight away, I know my difference is not going to be 0. Difference can never be 0. This is 10 and 11, 9 and 12, 8 and 13, all combinations I can try. But I cannot have 10.5 and 10.5. So my difference of odd position digits, even position digits can never be 0. 0 is not possible. So what do? Okay, 0 is not possible because 21 is an odd number. I cannot break it into 2 equal parts. Maybe the difference could be 11. Let me try that. So I want 1, 2, 3, 4, 5, 6 digits. I add these 3, add these 3. I want the difference to be 11. 11 is a very high number. The total of all the digits is only 21. So these 3 should be very high. These 3 should be very small. Again, I'm going to trial and error. Let me put these 3 as high as possible. Let me put 6, 5, 4. These 3 to be as small as possible. 1, 2, 3. Done. 6 plus 5 plus 4 is 15. 1 plus 2 plus 3 is 6. 15 minus 6 is 9. Still not 11. Or it can never be 11. I put the 3 digits maximum sum possible is 15. The remaining 3 digits, the minimum sum possible is 6. So the maximum difference is only 9. I cannot have the difference as 11. Obviously, difference cannot be 22. There's no number possible with difference 0, that the two sums being equal. No number possible with the difference being 11. Or how many numbers are possible? There is absolutely no number which has the digits 1, 2, 3, 4, 5, 6, each occurring once. That's a multiple of 11. Not possible. It's impossible to have it. Why? Because the sum of the digits is 21. I cannot break it into 2 equal parts. That is ruled out. That's out. So I cannot make it a 2 equal parts. Okay, maybe I can make the difference to be 11. That doesn't work either because the difference, maximum difference possible is 9. The highest sum is 15. The smallest sum is 6. 15 minus 6 is 9. So I cannot have difference as 11. There is no number possible. That's a multiple of 11. Should feel confident and mark 0. Right? Fine. For this one question saying I cannot understand. I'm going to go over this again. The digits The test of divisibility for 11, add odd position digits, add even position digits, and then find the difference. The difference should be either 0 or 11 or 22. The difference has to be 0. The two sums have to be equal. My total of all the digits is 21. Some 3 digits have to go this side, some 3 digits have to go that side. Total is 21. I can split as 10 and 11 or 11 and 10. I cannot split as 2 equal parts. 21 is an odd number. So I cannot have these 3 adding up to 10.5, these 3 adding up to 10.5. That's not possible. So the difference of the digits being 0, we cannot find a single number. The next step, difference should be 11. So 11 is large. Difference between two sets of numbers should be 11. The total itself is only 21. So let me start off by saying, hey, I want the difference to be high. So I'll put these 3 numbers to be very large, these 3 numbers to be very small, to start with, to see where I am headed. 6 plus 5 plus 4 is 15, 1 plus 2 plus 3 is 6. The maximum possible sum of 3 digits is 15. Minimum possible sum of 3 digits is 6. That difference is only 9. So I can never have the difference to be 11. Difference cannot be 11, difference cannot be 0, no number is possible. Lovely. I'm going to go to the next question. The sum of the digits of a 7-digit odd natural number is 3. How many such numbers are possible? Oh, brilliant, brilliant. 7-digit, 1, 2, 3, 4, 5, 6, 7. It's an odd number. So this digit has to be 1, 3, 5, 7 or 9. It's an odd number. Right? It's a 7-digit odd natural number. The sum of the digits is 3. Add all the digits, we'll get 3. So obviously, this digit cannot be 9, it cannot be 7, it cannot be 5. The sum itself is only 3. If this digit were 3, think about it, if this were 3, then all of these should add up to 0. We can only have 0, 0, 0, 0, 0, 3. That's not possible because then it will be a single digit number, 3. I want a 7-digit number. This number, this cannot be 0. So this cannot be 3. So my last digit is 1. I know that for sure. And I know my first digit cannot be 0. Sum of the digits is 3. First digit, already 1, this has to be 1, that we know. What could the first digit could be? First digit could be 1. First digit could be 2. First digit cannot be 3 because there's a 3 here, there's already a 1 sitting there, sum of the digits will become 4. The first digit could only be 1 or 2. Last digit has to be 1. Now I am through. So what will I do? I'll say there are 2 types of numbers. 1, 2, 3, 4, 5, 1. Or 2, 1, 2, 3, 4, 5, 1. Either the first and last digits are 2 and 1 or the first and last digits are 1 and 1. If there are 2 and 1, think about how many numbers are possible. The sum of the digits should be 3. It means all of these should be 0. Only one number is possible. So it's 1 and 1. The sum of the digits is 3. These two add up to 2. There should be one more digit sitting there being 1. That one more 1 could be here or here or here or here. 1, 2, 3, 4, 5 different numbers. The rest are all 0. How many numbers are possible? 5 numbers like this, 1 like this, 6 numbers totally. Beautiful question. It's an odd number, so the last digit is 1. It cannot even be 3. It's a 7-digit number. First digit cannot be 0. It has to be 1 or 2. It cannot be 3 because the last digit is 1. So we are thinking about numbers of the form 1 dash 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 5 dashes 1 or 2 5 dashes and 1. 2 5 dashes and 1, everything in between is 0. 1 5 dashes and 1, in these 5 dashes, one of those could be 1, everything else is 0. 5 different numbers are possible. 5 plus 1, 6. Right? Lovely. So we've reached the halfway mark. So I'm going to have a quick chat with you guys. Good to have all of you here. I hope you all enjoyed the Olympiad. So we do a wonderful course which is just like this Olympiad, but just slightly simpler questions. We won't have questions this difficult. These questions were very tough. But we do an online course completely, which we have classes for your batch. It will be every Thursday. I have quite a few of our students there on the chat window. I can recognize them. So what we do in those classes, we give material to study for through the week. But in that class, 6 to 8, we do a wonderful exercise. We say, hey, 6 to 7, take a test like PiMO' Mathematical Olympiad, and then 7 to 8, we'll discuss this. Just like this session. Only, it will be a tighter set of questions relevant to a particular topic and slightly simpler. And whatever you need to learn for that topic, we teach outside of that. So it's practically a course where every week there's something that you can learn, there's something that you can put together, and every 1 hour you take a test on what you have learned, all non-routine questions, all very much similar to what we are discussing today, and we discuss them just like how we are discussing now. We'll take question by question and tackle it slowly and go through the whole process. And I can tell you, usually our students take the 10-question test and they get like 2, 3 correct, and another 3, 4 they're very close to. Then by the time we finish 10 questions, you feel like, look, I've got the hang of this topic. Now I can give me 10 more questions just like this, I'll get 6 or 7 correct, which is the feeling I want to leave you with even at the end of the day today. Several of you might have done this 10-question test and gotten 1 question or 2 questions or 0 right. I don't worry about that at all. I want to reach a state where at the end of this, you feel like, look, give me a test just like this time I'll get 5 right. I've got the idea of this. I know how to do test of divisibility by 11 and figure it out. If a number is a multiple of 45, it should be a multiple of 5 and 9. For 5 there's a rule, for 9 there's a rule. I'll put these two together and get an answer. So all of those inferences we will make and build it brick by brick. And one objective that we have for all of this is to have lots of fun. So we have something that you learn, and then we do a test for an hour and discussion for an hour. We do this every week. So if you enjoyed the mathematical Olympiad, not the mark, not the score, not the rank, not the award, not the prize, not the percentile, none of that. Throw away all of that. The idea of grappling with a question. I know when I was growing up, I had a lot of regular math where you would be given a question and then you say, let the number of cows be C. Each cow has 4 legs. The total number of legs will be 4 into C. You have to write 4 into C. And if you didn't write that, the teacher will say steps are not proper. You've not kept a full stop. You didn't do this 2 lines, all of that. And I'm not blaming my teachers. They were wonderful men and women who taught me a lot of things. But the school system is superbly rule bound. They have to teach you to say, let the number of cows be C. Whereas, sometimes I feel that students can be thrown into the deep end and say, look, figure this out. I'm not writing you, right? You don't have to write number of birds is this, a number of cows is that, a number of bullocks is that. Try this question. I'm giving you a prime number where the sum of the digits is this. Find me how many numbers are there. So that idea is super powerful. And I want to create a course which completely says, go on, try this. I'm not giving you anything. Try this out. And then we'll discuss. I find sometimes just giving questions is not easy. You have to come back and say, hey, I told you this was a tough question, but actually what? It is not that difficult. Let me solve it with you. So we're going to do that. We do that as an entire course. So every week, practically, is one part of it is learning in theory. Another part of it is one Olympiad type 10 questions and discussion. And so if you have any of you saying, look, I enjoyed this PIMO and I want to have a go at it every week, reach out to us. There are plenty of places to just click on that and sign up and register, and you can check out the course, there are parts available, or just click and sign up. We'll give you a call and we can discuss this. Speak to your parents, we can chat with them. Lovely. Last question, if somebody who's saying 210000 could be a number, it can't be a number because we know the number is an odd number. 21 followed by 5 zeros is an even number. That doesn't work. 2 5 zeros and 1 is possible. 2 1 followed by 5 zeros is not possible. That will be an even number, and we don't do even numbers. We want only odd numbers. Okay. Lovely, lovely. I'm going to go to the next idea, next question. We're not done with the question, not done with the learning part. Right? Using all the digits 1, 2, 3, 4, 5, one can form the 5-digit number 1, 4, 3, 5, 2. It is observed that no 3 successive digits are in ascending or descending order. Very interesting. This sentence is very brilliant. No 3 successive digits are in ascending or descending order. Sometimes, some of these questions we just don't understand what is being said. If you understand it, becomes very, very easy. 3 successive digits. Successive, one after the other. digits, one digit at a time, 3 successive digits. So you take this number 14352, we are talking about 143 or 435 or 352. These three, 143, they are not in ascending order, they are not in descending order either. And so this is like the numbers are like the Olympic podium, gold, silver and bronze. And so like that, the middle number is higher. So it's not in ascending order, it's not in descending order. This one, not in descending order, not in ascending order. This one, not in ascending order, not in descending order. So the condition is that number should be like 14352. No 3 successive digits are in ascending or descending order. So we cannot have a number 1, 2, 3, 4, 5. Is in ascending order. We cannot even have 1, 2, 3, 5, 4. These three are in ascending order. We cannot have 3, 1, 2, 5, 4. These three are in ascending order. Any 3 successive digits we take, the first 3, middle 3 or the last 3, they should not be in order. That's the objective. Find the difference between the biggest and smallest such 5-digit numbers. Beautiful. And so now I'm going to try to track the biggest such. We want the biggest such 5-digit number and the smallest. Straight away, biggest such 5-digit number, I should start with 5. I have 1, 2, 3, 4, 5 to deal with. I want this number to be large. I should start it with 5. Maybe I can get nothing starting with 5, then I'll go to 4. But I'm going to try to start it with 5. Likewise, this I'll start it with 1. Now, I have 4 more digits. After 5, I put a 4 here, 5, 4. Then think about it. First digit is 5, second digit is 4. Third digit has to be less than 4, for sure. If I put a 4 here, the first 3 will be in descending order, straight away. So I cannot start with 5, 4. 5 I can start with. The moment I start with 5, I have to make sure that the second digit is not 4. Because if I put 5 and 4 here, 5, 4 something will be in descending order. Already I am in trouble. The first 3 will be in descending order. So I cannot have 5, 4. What is the next best? Put 5, 3. If I put 5, 3, I cannot put 5, 3, 2, 5, 3, 1. That will become in descending order. So obviously, my next digit has to be 4. Done. 5, 3, 4. I have 1 and 2 remaining. If I put 1 here, 5, 3, 4, 1, 2, 5, 3, 4, 2, 1. There are 2 possibilities. 5, 3, 4, 1, 2. These 3 are not in ascending or descending order. These 3 are not in ascending or descending order. These 3 are not in ascending or descending order. This number works. 5, 3, 4, 2, 1. That won't work because 4, 2, 1 is in descending order. This won't work. Or the largest possible number is 5, 3, 4, 1, 2. Exact same approach this side. I start with 1. My next digit cannot be 2. I put 1, 2. I put anything, 3, 4, 5, anything, that will become ascending order. This cannot be 2. Minimum beyond 2 is 3. If I put 1, 3, this cannot be 4 or 5. 1, 3, 4, 1, 3, 5, again trouble. This has to be 2. So 1, 3, 2 can form the first 3 digits. I can have 1, 3, 2, 4, 5 or 1, 3, 2, 5, 4. 1, 3, 2, 4, 5. 2, 4, 5 are in ascending order. This doesn't work. 1, 3, 2, 5, 4. This works. Or my 2 numbers, the largest possible number is 5, 3, 4, 1, 2. The smallest possible number is 1, 3, 2, 5, 4. We want a difference between the biggest and smallest such 5-digit numbers. Subtract 1 from the other. 12 minus 4 is 8. 10 minus 5 is 5. 3 minus 2 is 1. 40158. Brilliant question, but the trickiest part is in understanding this thing. No 3 successive digits are in ascending and descending order. Take out 3 successive digits and then say, okay, some 3 are in ascending or descending order, it won't work for me. Understand that constraint by removing layer after layer, 3 successive digits, extract it. All of these questions, you should write down one number where the condition is satisfied, one number where the condition is not satisfied, and say, okay, this is the condition. This should be, I should be careful about this. I cannot have a number as 134, and it won't work. Oh, okay, that's my idea. Then try solving it. Understand the question completely before trying to solve it. Lovely. So 53412 and 13254. Those are the two numbers. Difference is 40158. Brilliant. Let's go to the next one. Been a very tough question. Only 4% have got right. I think it's mostly got to do with not being able to understand this. If you'd understood this, I'm sure several of you would have tried to crack it. But you will find questions like that where you have to sit and pause and look at it thoroughly and say, oh, this is what it means. You have to take time out to try and understand that. That takes effort. So break it down step by step, but build that skill set of understanding it slowly, thoroughly. Right? Lovely. Let's go to the next question. How many positive integers less than 100 can be written as a sum of 11 consecutive integers? 11 consecutive integers. I'm adding them up. I need to have a sum less than 100. What can be done? Lovely. How many positive integers less than 100 can be written as a sum of 11 consecutive integers? Let me add 11 consecutive integers and then see where that happens. I'm going to add the 11 smallest possible positive integers. And so I'm going to say, let me do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll add all of this up. See where it takes me. That is the possible sum. As long as the sum is less than 100. Let's do this. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21. So far the sum is 21. 21 plus 7, 28, 36. So far it is 36. Plus 9, 45. 55 plus 11, 66. So I got one value. How many positive integers less than 100 can be written as a sum of 11 consecutive integers? 66 can be written as a sum of 11 consecutive integers. 66 is 1 plus 2 plus 3 plus 4 plus 5 till 11. Brilliant. 66 is one possible positive integer. Let's see, 66 works. What are the next one? Instead of going from 1 to 11, I'll say I'll go as 2, 3, 4, 5, 6, all the way till 12. One way of thinking about it is, I'm increasing each number by 1. So my total will increase by 11. There are 11 numbers. Each one I'm increasing by 1. My total will increase by 11. It becomes 77. I don't have to set an add. Or I can say 2 to 10 are all common. 2 to 11 are common in both these lists. Instead of 1, I put 12. It's like I take out 1, I introduce 12. Take out 1, put in 12, the total increases by 11. So 66 works, 77 will work. Now I've got a pattern. Next one, put 3, 4, 5, all the way till 13. Total will be 88. Then you put 4, 5, 6, 7, 8 till 14. Total will be 99. You put 5, 6, 7, 8. Total will be 110. Hey, this is not possible. We don't need to worry about 110. We need to worry only about these 66, 77, 88, 99. Those are the 4 positive integers that are possible. But, how many positive integers less than 100 can be written as a sum of 11 consecutive integers? Remember, it's a beautiful question. The 11 consecutive integers, they need not be positive. Only my answer should be positive. What does that mean? I need not have started with 1. I could have started with 0. 0 to 10. What will that add up as? Exactly same process. From this total, subtract 1, 1, 1, 1, 1, 1, 11 times, or that total will be 55. That's also possible. What is preventing us? Sum of 11 consecutive integers from 0 to 10, adding up to 55. This is the positive integer. These integers need not be positive. The question is not saying how many positive integers less than 100 can be written as a sum of 11 consecutive positive integers. These need not be positive. Only the sum needs to be positive. So 55 is also possible. What else is possible? 44 is possible. How is 44 possible? minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These will all add up to 44. How do I know that? I know that 0, 1, 2, 3 till 10 adds up to 55. Subtract 11. 44 is possible. Going from minus 2 to 8 should be 33. Minus 3 to 7 should be 22. Minus 4 to 6, this should add up to 11. Minus 5 to 5, this should add up to 0. Hey, my sum should be positive. The 0 I won't count. Or I could have my total as 11, 22, 33, 44, 55, 66, 77, 88, 99. 9 possible values are there. Super question. The most important part is that all 11 integers need not be positive. Only the sum needs to be positive. Keep that in mind. If all 11 needed to be positive, we can only think in terms of 66, 77, 88, 99. Only 4 numbers. The numbers, all 11 integers need not be positive. Only the sum needs to be positive. So the sum could be 11, 22, 33, 44, 55, 66, 77, 88, 99. 9 different totals are possible. And so be very careful with the detail. Funny studies answers. I think several of you might have got the answer as 4. Think about 66, 77, 88, 99. Be careful with detail. Lesson learned. Go to the next one. The product of two positive integers is 2 power 9 into 3 power 5 into 5 power 4 into 7 cube. This is prime factorization. This product of these two numbers has 9 2's in it and 5 3's in it, 4 5's in it, and 3 7's in it. Brilliant. Fine. So you need what that means. If I'm putting two numbers, two blocks, and multiplying these two to get this, that means between these two numbers I'll have 9 2's. Between these two numbers I'll have 5 3's. Between these two numbers I'll have 4 5's. Between these two I'll have 3 7's. What does that mean? This number could have 6 2's. This could have 3 2's. This number could have 4 3's. This could have 1 3. This number could have 5 power 1. This could have 5 cube. Could have 7 power 1. This could have 7 square. This is one possibility. Right? These two numbers will multiply to give us this. Our number has 9 2's in it. 6 here, 3 here. It has 5 3's in it. 4 here, 1 here. It has 4 5's in it. 1 here, 3 here. It has 3 7's in it. 1 here, 2 here. I can potentially break this like this. Their sum may be divisible by. May be divisible by. I don't even understand what this means. May be divisible by. Let's look at this example. 63. 63 is 7 into 9. 7 into 3 square. Will it be divisible by 7 into 3 square? This number is a multiple of 63. 7 and 3 square is sitting here. This number is not a multiple of 63. This combination, this doesn't work. Some other combination, it may work. Right? And then we'll have to worry about each of these. Beautiful question. And I'm going to find out whether I take each of these and I try to create a combination that works. That's my objective. I'm going to try to break this into two parts such that the sum is a multiple of 63. Brilliant. 63 is 7 into 3 square. I'm going to try to do this by saying, hey, this didn't work out, but tell you what, I'm going to create one number that's a multiple of 63, another number that's a multiple of 63 within this set. Or I'll have a 3 square into 7 here and a 3 square into 7 here, and then see if I can fill the rest in. What does that mean? 3 square into 7, 3 square into 7. There's a 3 square here, 3 square here. I have 5 3's with me. I put 2 here, I put 2 here. I'll have one more with me. Maybe I'll keep it here. 7 and 7. I have 2 7's I've accounted for. I have 7 cube. I have one more 7. I'll put that here. This number is a multiple of 63. This number is a multiple of 63. I I don't care about how I put the remaining. Maybe I'll put all 2 power 9 here. I'll put all 5 power 4 here. This works brilliantly. I've broken this into 2 parts such that this is a multiple of 63, this is a multiple of 63. That means if I add one multiple of 63 and another multiple of 63, I will definitely get a multiple of 63. Their sum may be divisible by 63. Of course, it may be divisible by 63. That worked, but I'm not too fine. I'm too comfortable. I look at the first thing, it may be working. Now I'm worried. What if all of these are working? Maybe I'm making some mistake. So what am I going to do? I'm going to say, hey, I'm going to find a mechanism whereby I can try to do this also. If I can do this, then I'm in trouble. Everything is possible. If I cannot do this, then I'm confident. Only this works. I've tried only one choice. Let me do the other choice also. Number is a multiple of 27. That means 27 is 3 cube. I'm going to take this number. I want this number to be a multiple of 27. This number to be a multiple of 27. So I put a 3 cube here and a 3 cube here. Oh, that's not possible. I have only 5 3's with me. I put 3 3's here. I don't have 3 3's to put here. Put a 3 cube and 3 cube. I need 6 3's. I have only 5. It is impossible to have 2 multiples of 27. Now I get another interesting idea. If I add 2 multiples of 27, I'll get a multiple of 27. If I add one number that's a multiple of 27 and another that's not a multiple of 27, I cannot get a multiple of 27. But I can have 2 numbers that are not multiples of 27 that add up to give me a multiple of 27. Think about this. 13 plus 14 is 27. This is not a multiple of 27, this is not a multiple of 27. But they can add up to give me a multiple of 27. Is that possible? I have 5 3's with me. If I put this to be not a multiple of 27, that will end up being a multiple of 27. If I put only 2 3's here, 3 3's will have to go there. One of the 2 numbers has to have 3 cube in it. But both numbers cannot have 3 cube in it. So any which way I break, one of these will be a multiple of 27, other one will not be a multiple of 27. I add these two, I cannot have a multiple of 27. It will never happen. So 27 is ruled out. 32, now I've got the hang of this. 32 is 2 power 5. That means this number needs to be a multiple of 32. This number needs to be a multiple of 32. That means I'll have to put a 2 power 5 here and a 2 power 5 here. Not possible. I have only 9 2's with me. I cannot put 5 2's here and 5 2's there. I don't have it. At the same time, one of these 2 numbers will definitely be a multiple of 32, because if I put 4 2's and 4 2's, I'm using only 8 2's. That's not right. I have to use up all 9. So definitely when I break this, one of the numbers will be a multiple of 32. The other one will not be a multiple of 32. I cannot add this and get 32. 32 is out as well. 196. 196 is 98 into 2. 98 is 49 into 2. 49 is 7 square into 2 square. So I want 2 numbers. One that has 7 square into 2 square. Another one also has 7 square into 2 square. Not possible. I have only 3 7's with me. I cannot put 2 7's here and 2 7's here. I have only 3 7's. So I cannot have 2 numbers that are both multiples of 196. Not possible. I cannot have a scenario where both are not multiples of 49. That's not possible either. Because if I put 7 here, there will have to be a 7 square. So I will have 2 numbers that are multiples of 49. So they will add up to be a multiple of 49. So there will be one number that's a multiple of 49, another one that's not a multiple of 49. I add these two. I will not be able to get a number that's a multiple of even 49. There's nothing possible that's a multiple of 196. Therefore, this one also does not work. Only one possible answer, 63. I can break this into 2 parts such that first one is a multiple of 63 and second one is a multiple of 63. I simply cannot break it into 2 parts such that first and second are multiples of 27. First and second are multiples of 32. First and seconds are multiples of 196. Not possible. Doesn't work. And beautiful question. Really, really, really tough. I see somebody saying, please stop fighting and focus on solution. I don't even know what the fight is, but if you're fighting, please stop fighting and focus on the solutions. If you focus on the solution, there's something to learn. Otherwise, you're just wasting your time. Lovely, brilliant, challenging questions. You learn by hanging in there for longer and longer. Fine. Don't spam, don't be rude. It doesn't work, it's uncalled for. If you don't agree with something, disagree without saying anything. You can't keep discussing every little thing with every single person you see on the internet. That doesn't work. You're going to live your entire lives with internet. And it's a very interesting thing. You're probably the first generation that's going to live its entire childhood upwards with internet and social media. A discussion platform that gives you anonymity and comfort and peer group is present. You can comment to people whom you have never met in your life, whom you will be confident you can never meet in life. And sooner or later, you'll realize that you can write comments and respond without knowing the identity of the other person, nor revealing your own identity. And so that is in that setting that you need to have your kindness hat on, your compassion hat on, your good civic sense hat on. Always be civil. You disagree with something, you should say, hey, do I know this guy? Can I engage and change their opinion? This is a meaningful discussion to have. If not, don't be rude, leave it. Don't make anything worse. You should be able to agree and carry on with your life. Disagree and carry on with your life. Should never compromise what you can take from an interaction by engaging in some discussion with a person who you have not met, not likely to meet. Right? So don't get, because you're going to live your entire life in this world. So keep that in mind. Fine. Lovely. Somebody saying I should be louder. I will be louder. Definitely. This is Vishaka Vaswani. I will be louder. Hello, hello, hello. Hello, hello, hello. I hope you can hear this very clearly. Hello, hello, hello. Hello, hello, hello. I'm going to just check to see if my volume is getting picked. Hello, 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 hello. Check, 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 check. Voice is a bit feeble. I'm going to fix that. Give me a second. I'm just going to see if I can fix that in some form. Hello, check, 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 check. Hello, 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 hello. Hopefully, this is fixing that. I'm going to just see if I can make one other change. Hello, 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 hello. I hope the volume is better now. I can hear your voice is good for me. Good, good, good. Hello, 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 hello. Hello, hello, hello. I hope you can hear me much better now. And hello, check, 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 check. It is clear. Somebody who's saying super clear. Come out as stopper clear, but I hope it's super clear that you indeed wanted to type. Lovely. So it did work. The sound gods are happy with us. A 2021 digit number is multiplied by 54. Straight away, I know I cannot do this question algebraically. I cannot write down a 2021 digit number. The last digit is 2 and the second last digit is 4. I have a 2021 digit number multiplied by 54. Last digit is 2, second last is 4. This is 42, like this. The same number, let's call this number as n. Same number n is multiplied by 46. What will be the last two digits? Brilliant, brilliant question. Fine, one of my favorite questions. Fine. I'm going to do this by a very painful, slow method and then give you a beautiful method at the end of it. If I do it the other way around, you won't listen to the painful method. Fine. Suppose I multiply this in a traditional way. That means you're going to write down a lot of digits here and multiply by 4, leave out one slot, write down a lot of digits here. Lovely, brilliant. So I'm going to think about, when I multiply by 4, this digit here has to be 2. Nice, that is obvious, because this 2 is only going to come here. Now I'm going to think about just this digit. What can this be? I don't care about the 2021 digit number. I care only about the units digit, nothing else. The unit digit were 1, 4 into 1 would be 4. Doesn't work. 4 into 2 would be 8, doesn't work. 4 into 3 would be 12, that works, it could be 3. 4 into 4 is 16, this will be 6, doesn't work. 4 into 5, 20, 0, doesn't work. 4 into 6, 24, nope, nope, I want this digit to be 2. 4 into 7, 28, no. 4 into 8, 32, that works, so it could be 8. 4 into 9, 36, this has to be 6, that doesn't work. 4 into 10, 4 into 0 is 0, not 0. The units digit of our 2021 digit number is either 3 or 8. Lovely, brilliant. Now I'm going to break it into two parts. So now I have a 2021 digit number, ends in 3, multiplied by 54. Or 2021 digit number ends with 8, multiplied by 54. Brilliant. Now I multiply this, 4 plus 3 is 12, 4 into 3 is 12, 2, 1 carried over. 5 into 3 is 15, this digit would be 5. And then my last two digits are 4, 2. Just writing down that product, nothing more than that. Here what could it be? 4 into 8 is 32, 2, 3 carried over. 5 into 8 is 40, 0, 4 carried over. My total is 42. The last digit could be 8 or 3. That much we know, that much we have inferred. Now think about this. This 4 into 3 is 12, 2 and 1 carried over. 5 into 3 is 15, this is 5. I carry over a 1 from the previous sum, or leave out even this carry over. This is 5, this is 4. What should be here for this total to end up to 1? So forget this one, that is perhaps confusing. I'm going to delete this, I'm going to delete this. This digit is 5. What should be sitting here for us to get a 4? Think about that. What number here will give us a 4 here? This 2 drops down. Something plus 5 ends in a 4. This cannot be 4, it has to be 14 with something carried over, or this has to be 9. Brilliant. In this case, 5 into 8 is 40, this is 0, this is 2, 4 into 8 is 32. What should go before that? This should also be 4. But I already have a 1 carried over here. 4 into 8 is 32, not just a 1, 3 carried over. 32 is, so 4 into something plus 3 should be 4. Not possible. 4 into 8 is 32, 2, 3 carried over. And then this digit, even if it is 1, 4 into 1 is 4, 4 plus 3 is 7. That's not possible. It can never be 4. 42 is not a multiple of 4. This number cannot be a multiple of 4. This can never be 4. Or this possibility is ruled out. Our only possibility is this being 92. Brilliant. That this digit is 3. That digit cannot be 8. This completely we kill. Nice. This is 3. Let's see what we can infer about this digit. This has to be 9. 4 into something plus 1 carried over. 4 into something plus 1 should be 9. 4 into what plus 1 is 9? 4 into 2, 8 plus 1 is 9. This could be 2. Nice. But not just that, this need not be 9, this just has to end in 9. And so 4 into 2, 8 plus 1 is 9. 4 into 3, 12 plus 1 is 13. 4 into 4, 16 plus 1 is 17. 4 into 5, 20 plus 1 is 21. Doesn't work. 4 into 6, 24 plus 1 is 25. Doesn't work. 4 into 7, 28 plus 1 is 29. That will work again because this will be 9 with the 2 carried over. So these two digits would be 23 or 73. Now we are getting somewhere. So my last two digits were 23. I multiply by 54. My last two digits will be 42. My last two digits were 73. I multiply by 54. My last two digits will be 42. Why? 4 into 3, 12, 2, 1, 4 into 2, 8, 8 plus 1, 9, 5 into 3, 15, 5, 1 carried over, 2, 14 works. 4 into 3, 12, 2, 1 carried over, 28 plus 1, 29, 9, 2 carried over, 5 into 3, 15, 5 works. My last two digits would be 23 or 73. Brilliant. Now I've got this far. I want to think about multiplying by 46. What do? The last two digits could be 23 or 73. I'm going to assume both. I'm going to erase this. I'm going to erase this. I'm going to erase this. I'm going to knock this off. I'm going to knock this off. I'm going to knock this off. Then I'm going to say, hey, interesting so far. Now I'm going to multiply this with 46. Multiply this with 46. See where it takes me. 6 3s are 18. 8, 1. 6 2s are 12. 12 plus 1, 13. 3, 1. 4 3s are 12. 2, 1 carried over. Or this will be 8. 3 plus 2 is 5. Likewise here. 6 3s are 18. 8, 1. 6 7s are 42. 42 plus 1, 43. 3, 4 carried over. 4 into 3, 12. 2, 1 carried over. Add these two, 8 and 5. Or the last two digits in both cases is 58. That's what we want. Obviously, we cannot find this 2021 digit number. Just not possible. But if you do this methodically, then you can find what could be the last two digits. There are still two possibilities. But for both those possibilities, if you multiply by 46, the last two digits is 58. 58. That works. Now I'm going to tell you the shortcut. A much simpler way of doing this. Right? There is this number n, 2021 digit number. Multiply n into 54. I get some large number, 42. And the last two digits are 42. You want to find this number n multiplied by 46. What are the last two digits? Tough question, obviously. I said n into 54, n into 46. N into 46, we need to find the last two digits. What am I going to do? Multiply a number by 54 and multiply a number by 46. I look at this and say, look, nice, 54, 46. I'm going to open my eyes and see, hey, brilliant, 55, 54, 46. There's something that pops out. Is there some genius sitting in 54 plus 46? 54 plus 46 is 100. If I add these two numbers, it is nothing but n into 100. N into 100, n is a 2021 digit number. Obviously, I cannot find n into 100. I don't even know n. But the one beautiful thing I know about n into 100, that is the last two digits are 0. This last two digits is 42. This last two digits is something. These two last two digits should be 0. 2 plus something is 0. That unit place has to be 8. 2 plus 8 is 10, 0, 1 carried over. 1 plus 4, 5. This has to be 5, 10, 58, through. 54 plus 46 is 100. If you use that idea, you can write down this answer in seconds. This number gives 42. This number gives 58. You add these two numbers, the last two digits should be 0, 0. That works. This gives 42. If you add these two, you get 0, 0. The missing part of the jigsaw is 58, 58. 54 plus 46 is 100. You use that idea, we are through. An absolutely delightful question. Beautiful, difficult, but delightful. Lovely. I'm going to go. This again is a nice favorite question of mine. Beautiful question. 4 into 230 plus x, the whole square, is 8686-4. Brilliant. If you square this, and you have a multiple of 4 square, that means this will be 4 square into 230 plus x, the whole square. You have a number that's a multiple of 4 and you square that. So that will be a multiple of 16. Brilliant. 4 square is 16. I have a number that's a multiple of 4. If I square it, it will be a multiple of 16. If I have a number that's a multiple of 3, if I square it, it will be a multiple of 9. That much I know. So this number is a multiple of 16. Or our number 8686A4 is a multiple of 16. It is 16 into something. It's a multiple of 16. It is definitely a multiple of 8. Or I know this number 6A4 is a multiple of 8. Nice. And so if I multiply this number by something, I should get 6A4. Right? So 8 into something with no remainder, I should get 6A4. So 600, let's keep that separate. 600 divided by 8, let's do. So 7 times 56, 40, 5 times 40, 0. 600 is a multiple of 8. The last 2 digits, 600 plus A4 is what we are looking at. So it would be, we are looking at numbers like 614, 624, 634, 644, 654, all of that till 694, 604. 600 is a multiple of 8. Is not add 4, it won't work. Add 14, 624 is a multiple. 634, no. 44, no. 54, no. 664, not a multiple of 8. Or is 664 a multiple of 8? Yes, 664 is a multiple of 8. That is possible. 664 is a multiple of 8. 674 is not possible. 684 is not possible. 694 is not possible. These are not even multiples of 4. 684 is not a multiple of 8. So the last 2 digits would be 24 or 64. But we have a number which is 868624 or 868664. Thought about them being multiples of 16. So I can divide this by 16, I can divide this by 16 and get the remaining part. I'm going to do that. I'm going to take 868624 divided by 16. 868624 divided by 16. 16 5s are 80, lovely. 68, 16 4s are 64, lovely. 46, 16 2s are 32, nice. 142. 16 into 9 is 144. 16 into 8 is 128. I have 144 remaining. So I have 868624 to be 16 into 54289. Lovely. 868664. I have 868664. This number plus 40. Number is a multiple of 16. I add 16 to it, it will be a multiple of 16. I add 32 to it, it will be a multiple of 16. I add 40 to it, it won't be a multiple of 16. I don't have to worry about this. So I have to worry only about this. Or straight first step, I know A is equal to 2. Now this 4 square, 16 I have taken care of. 230 plus x, the whole square is 54289. This also is tricky. I don't know how to do this. 54289 is a large number. And so 3, let me think about 230 square. 23 into 23 is 69 and 46 is 529. So 230 square is 52900. This is 54289, slightly bigger. 240 square, 24 into 24 is 576. 240 square is 57600. This number is in between these two. So we're looking at a number in the 230s. You square that, we should get 54289. So it's an odd number. So my answer is 231, 233, 235, 237 or 239. 231 into 231 will end in a 1. This ends in 9. This is out. 233 into 233, that's possible. 235 into 235 will end in a 5, is out. 237 into 237, that is possible, will end in. 239 into 239 won't work. So our answer, this number, either 233 or 237. Let me try 233. It is not 237. 233 into 233. 3 3s are 9, 9, 6, 9, 9, 6, 6, 6, 4. Let's add up this. 9, 18, 1, 10, 16, 22, 2, 2, 8, 14, 4, 1, 5, 4, 2, 8, 9. Is that what I had? Yes, true. Or this number should be 233 or x is 3. We already found a is 2. A plus x, 2 plus 3, which is 5. Once again, a very tough question. We go step by step. We say, hey, this number should be a multiple of 16. So we get to find what a is. We locate a to be 2. Got a to be 2. Nice. Now with a as 2, remove that 16 from it. The remaining square works. It should be between 230 and 240. 233 works. Done. A nice, tough, challenging question. Lot of computation. With a calculator, it is simple, but otherwise also doable. Nice. We're done with the session. Now I would want all of you to like the video and subscribe to the channel, share it, tell people how it works, all of that. And so we've done a full session on non-routine questions. The mathematical Olympiad is a brilliant exercise in doing all kinds of different questions. And more than doing just questions and trying to solve them, seeing the solutions is really the real deal. So I've tried to incorporate that as much as possible. Just to recollect, to do a very quick recap, want all of you to go through this and be super clear about it and solve these questions. Doesn't matter what score you have selected, what score you've got. Give me a second, somebody is calling me. Doesn't matter what score, what mark, what rank, what percentile, none of that matters. What matters is that, hey, you kind of came away with the feeling of, hey, I learned this new idea. I know that 54 plus 46 is 100. I can use it somewhere. I know the test of divisibility is to test 11 pairs of digits and see if something can come from there. I know if I can test of divisibility of 8, I can use and find a digit if I'm given a square. Those ideas are super crucial. Right? All the best for all your mathematical journeys from here on in. Hope you have lots of fun learning math. And think of math as something that's intriguing, fun, thing where you can feed your curiosity, enjoy yourself, have a blast, have those feelings towards learning, not mark and score and rank and all of that. This exam was incredibly tough. And I think if we had taken this test, the guys who conducted the test, if we had taken it, we would simply not have scored more than 6 or 7. We have set the paper. So it's beautifully tough. But there is lots to learn from this. And if you like the idea of saying, hey, I want to learn something new, I'm going to figure something new out, I might get humbled by this exam, I might not get good marks at all, but hey, it's a good opportunity to learn, then give us a call, give us a ping. This is a number. Oops. This is a website. Check it out. Reach out to us. We'll give you an outline about how the course is. Wonderful. Good. Thank you. Have a good time. And I will catch up with you soon enough with the next edition of this. Right? Now how to check the results. The results are going to be out by 7:30. That is 2 minutes from now. Go on to the same course inside the Olympiad. Just click there and you'll be able to see the results. You'll be able to see your score. You'll be able to see how many you got right, how many you got wrong. What are the correct answers, what is your score, everything you will get. So go to the same interface, PiVerb.com, click on the same link, go to the same place, click at the same test. In 2 minutes from now or 1 minute from now, you'll be able to click and see your score, results, explanation, solutions, answers, everything. Solutions are obviously available here on the video. The explanation you'll be able to find there. Lovely. I'm going to sign off. Check out your results. See how much you have scored, but don't worry about whatever marks you have scored. It is not about the mark. It's about saying, hey, I'm curious. I want to learn this new idea. That is the most important thing. Lovely. I'm going to sign off. I'll catch up with you in the next edition of Olympiad.